In this video, we will discuss the topic Hooke's law. First, we will go through the basic history of this law. So, who was Hooke? There was a scientist with the name of Robert Hooke who first proposed this idea and introduced and performed an experiment on spring and metal wires, all the substances that have elasticity in it. So, he performed an experiment on springs and then he loaded the springs with weights like this. There he loaded its weights like this, and then this is another weight, then this. So what is the difference between these three springs? All three springs have same weights, but why there is less elasticity and there is more elasticity? Because of the force. So what was the Hooke's law? That the force applied on any substance is directly proportional to its extension. Extension means the elasticity of an object, the elastic ability of an object, how much a substance can stretch, like this. So Robert Hooke applied less force on this spring, a little more force on this spring, and the greatest force on this spring. So because of the little force on this spring is stretched less. Here Robert Hooke applied more force, that's why it is more stretched here, and this is the most stretched spring because of the greatest force applied on this spring. So Hooke's law states that extension of an elastic object is directly proportional to the force applied as long as the elastic limit is not exceeded. The force applied on an object is directly proportional. So the formula is F equals to Kx. F means force, K equals to spring constant, and X equals to extension, means the stretchable ability of an substance. So this is the spring, this is the weight here. The force applied on this spring, the force, that means F, on the spring is directly proportional to extension. This is the extension, how much a spring can be stretched. So this is equals to X. The more you apply the force, the more the spring will be stretched. And K equals to spring constant. Spring constant means the ability of a spring to be stretched. Every substance has different elastic limit. A spring has different elastic limit than if you use metal wire instead of spring. This has different elastic limits. So K is spring constant, is different for different substances. So F equals to Kx. This is the formula of Hooke's law. Elasticity is the ability of an object to return to its original shape after the force is removed. Elasticity, what is elasticity? The ability of an object to return to its original shape. If we apply the force on this spring, the spring will be stretched, but after some time it will go back to its original position. Like this is the original shape of the spring. When we apply force on the spring, it will go back again to its original position. This is the elasticity. And materials like rubber bands and springs are elastic. There are some other substances or materials as well, like metal wires. Metal wires are also stretchable, like rubber bands and springs. These are the graphs. This one is a straight line graph. What does it mean? This is the extension value, like how much a spring can be stretched, and this is the force that we apply on a spring. So this is a straight line graph. That means till this point the spring is stretchable. You can stretch, you can apply a force on the spring and the spring will not deform its shape, it will stretch along. This is the straight line graph, and this is the curve. This is the curve shape graph. That means till this point the spring is stretchable, but after this point there is a curve. That means this is the limit of proportionality, elastic limit. After this point, beyond this point, the spring cannot be stretched. It is not stretchable, it will deform its shape, it will not go back to its original shape, or it will deform, or it will break down like this. If we apply more than the required force on a spring, like if we apply the force here, after some time it will go back to its original position. If we apply extra force on it, it will not go back to its original position. original shape, it will deform or it will break like this. Okay, so this is the elastic limit of a substance. After this point, it will not come back to its original shape. That is the meaning of a curve graph. Now, what are the real world applications? Here we use the elasticity concept. There are trampolines and then spring balances. Trampolines, they have springs in it, and spring balances which are used to measure the weights. Like this, if this is a spring and then there is a weight underneath, and you can measure the objects when you put on this spring. So these are the real world applications where you can use this concept of Hooke's law. Now if we see one example using Hooke's law, a spring extends by 0.03 meter when a 1.5 Newton force is applied. Find the spring constant. What is the example? A spring extends by 0.03 meter. That means the extension value, this is the length, how much you can extend a spring is 0.03 meter. This is the value of x, which is 0.03 meter. Then you have force, 1.5 Newton force is applied. The value of F is 1.5. So two values are given and we have to find the third value, which is the spring constant, and spring constant is represented by K. So formula is F equals to Kx. Hooke's law states that force is directly proportional to extension. So this is the force and this is the extension. So K is spring constant, F and K's values are given. We have to find the value of spring constant, which is K. So we will divide this value with force. K equals to F over X. F is 1.5 divided by 0.03, which is equals to 50 Newton meter. Why the unit of spring constant is Newton per meter? Because the unit of force is Newton and the unit of extension is M. So it is Newton per meter. We will shift meter into numerator. Its power will become -1. So it is Newton per meter, 50 Newton per meter. Practice more questions like this at home, like these numericals. This was the whole concept of Hooke's law.